Yeah, g'day, and welcome back to my shed.
That's not your shed.
Well, there's enough old iron here that no one's going to notice. So before I left for vacation, I was working on new cylinder head models for my Redrup Radial engine project. Let's take a look. You might remember I made a set of cylinder heads and got as far as starting to machine them. That's when I found that I hadn't considered the clearance here, and these scars I didn't want to live with, and that's why I needed a redesign. That was basically fine. I got stuck into doing that redesign, and while I was at it, I decided to try and improve some aspects of the casting. Because on previous prints I got a kind of rough surface finish in the combustion chamber here, it was recommended that I use proper PLA support material, and since I was given some with my printer by Bamboo Labs, better give that a go. Alright, that was an overnight print. Let's see what they look like. It was recommended that I use a setting called ironing, where the head of the printer runs back over the part to try and smooth it off and reduce layer lines, and that seems to have done quite a good job. Obviously here you're still going to get some sort of beach marks as the part tapers so flat away. How did that support material work? Okay. So it didn't use the correct support material. I guess it's not just set and forget, you need to do some sort of setting for that, I guess. I better look that up. I'd been in constant contact with Barton, the old foundryman, and he gave me a couple of suggestions. The first thing he recommended was trying to avoid using a split pattern wherever possible, because split patterns, they're not very rigid, they tend to move a little bit and flex a little bit, and that all causes some defects. Right, so here's my next attempt. I did the layer line ironing here, but it didn't work quite as effectively as the first time. What I also did was to put in a layer of proper supporter material between the normal PLA and the part, so that popped off much easier than when I just used PLA. Right, now I printed it as a split pattern because it's easier to get all the geometry to stay flat and stuff doing it this way. Right, I'll just put in the alignment pins first. Oh yeah, it's fitting really nicely. No gaps. Yeah, that looks great. First thing I've done here is I've switched to a solid pattern. Then of course I've got the issue, if I just laid this down in my flask and started ramming, I'd have sand going up underneath that lip. To address that, rather than using the split pattern, oh look at this, just flawless prints every time. Brilliant. Because this is not actually part of the pattern, I just use one of the draft settings with low resolution. I did use ironing because I think that's my new favorite setting. Even on this very coarse layer line, it still does a very nice job. I decided to design up an Oddside, as they're called. Now an Oddside is just a plate to bring the sand up to your split line. And I've designed that so that on the one hand the pattern fits, and of course the pattern is scaled 1.5% larger than the model, because you get about 1.5% shrinkage in aluminium. Designed it to a nominal, then in my slicer I scale it by 1.5%. And therefore, I of course had to scale the Oddside board as well. I haven't quite got the size perfect, so I've got a wee bit of motion there, but that doesn't matter because I'm not going to use this pattern anyway, but we'll get to that. I put a spike in the middle of the Oddside just to support that loose part, so as I'm ramming, the loose part doesn't retract back out of the mold. That's the first improvement. The idea being that, so you ram up the sand on the drag, that first part, then when you flip this over, take the Oddside off, you can then ram up the second side and you've already got sand at that split line. One of the other things I had issues with was I had designed it so that I'd pull the top portion of the pattern off, leaving the loose part in the mold, and then pull that out at its angle. It worked better than I expected, to be honest. I was really quite happy with the results I was getting with that, but it was pointed out to me that if I could keep the pattern in the mold and pull the loose part out through the pattern, that would of course support all that sand and take away any risk that the removal of the loose piece damages the sand. That's what I've done here. And I was able to eventually work out how to do the filleting on this better. So you can see here that I do have fillets like down through this whole area. By doing Boolean subtracts on this, I managed to get all of these radiuses and all of these fillets in the model, so I shouldn't need to bog this anymore. I'd basically gone back to scratch, and although this pattern looks quite similar to the previous one with slightly smaller spark plug boss, I'd gone back and drawn it all from scratch again. I was just getting ready to start thinking about casting them when Lewis, he had found that there'd been an auction in England. A restored Redrup Radial had actually gone under the hammer back in April, which, had I known that, I could have done a GoFundMe and just gone and bought one, The cool thing about this is, for the auction, there's these high-resolution pictures. One glance at those high-resolution pictures showed me, man, my head's not right. I need to redesign it again. So if we look at this cylinder head, the first thing we see is it's got text on it, and mine didn't. So I'm going to have to work out how to put text on it, and the text is also not in a straight line, it's curved, which is probably quite easy to do if all you're doing is sticking little casting lettering sets. That's probably what Redrup's foundry would have done. The second thing we notice is this through here is more pointy than I'd made it, but that's pretty easy to change. What I'd completely missed is if you look along this row here, you can see there's actually an additional step in here. Like, I'd made this whole area basically just dead flat from this area right through, but above the combustion chamber there's kind of a secondary level which it rises up to. Whoever the pattern maker who did this, they weren't really into radiuses, because you can see here there's quite a sharp edge along here. There's not much of a radius below it. There's not a great radius there. One thing I can't be totally sure about is, are those cylinder heads even original? This motorbike has been restored, and Louis picked up that it's definitely been modified for smaller spark plugs. So it's not impossible that those heads are actually also just somebody else's modern interpretation. I can't say for sure, but it's the best thing I've got to go off, so that's what I'll go off. It seemed quite simple in a way to go through and make those changes. Add a few letters, make some radiuses a bit sharper, add sort of an extra layer above the combustion chamber. The worst thing about it is I can forget using the Petrobond. That surface finish is way too good. It all ended up way more difficult than I expected. I put a lot of work into this last night. I ended up having to use the help forum from Linux CNC, but eventually this is my new pattern. I ended up working yesterday until about 11:30 in the evening, and then pretty much all day today. I've probably done maybe 8 hours work on it to get the whole thing finished, but luckily I did. I should be able to show you. It's currently printing. One of the cool things about the bamboo printers is you can kind of stalk them the whole time. They have that monitoring function, which I find kind of cool. I'm doing this in PETG. I used up the rest of my yellows, so after a few layers, I had to switch over to a new spool, which is green. Louis's been very busy. He's done a whole bunch of beautiful hand sketches, and he said I'm allowed to use those, so they'll definitely be finding space in the future videos. He's also way, way ahead of me in the whole conceptual build of the engine. He sent me this today. Yeah, as you can see, it looks like this is going to be quite a challenging thing to actually cast. Mail time. Since I need to fill the layer lines on my models, I got just some spray fill. I figured I'd buy 3. I use quite a bit of this stuff. Nice Brazilian colours there. The proper support material definitely comes off a lot easier. Not quite as easy as with PLA, but still definitely easier than having no separation between them. Now I've got both my original design plus the one with the writing on it, so I figure I'll give them both a build up with some high fill primer. Hopefully they'll give me a little bit of rounding in around the letters and also hopefully fill up the striations on this one. Yeah, that might be a little bit too much, but that one's looking quite good. Okay, I probably should have read the description of that auction, because it actually says in there that those cylinder heads are not original. They were done during the restoration, so I assume 1970s or something. I guess my patterns with the writing on them are not original, so I'm probably not going to use them. But anyway, let's move on to casting. One of the points that was made by Martin, the old foundry guy, is that I've been running my green sand too dry. So let's add the water. I'll add a bit more than I'm used to. Okay, so that's about where I would normally have it. So I'll just add a bit more water than that. All right, let's see how that works. Okay, well, since I went to all the effort to make the two different models, I might as well use them both. This I think is more authentic. This is obviously the replica, but I kind of do like it with the logo on it, so I'll do both. Well, that's a failure. Yeah, pretty disappointed there to try that again, but the lettering looks fantastic. The Oddside seems to have done its job nicely. Right, let's try this one again. Right, now let's try the other one. All right. Okay, so here's the normal one. I didn't get a very good surface finish here. I think my issue is when my sand is a bit more moist and I force it through the sieve, it makes like little balls of sand, and that's the texture of them. I'm not crushing them down hard enough to take away that texture. It's kind of rough, but reasonably even. Now on this one, the upper side here is looking pretty good, bit of flashing around the edges, but that'll come off easily. But I did have this dropout down in here, and also there's a defect here. But this is probably just going to be a machining test piece anyway. And now switching to the one with the writing on it, I'm pretty amazed at how well that came out. That's just my homemade green sand, and the lettering came out almost perfectly. Same on the other side. Unfortunately I had a bit of a dropout along the edge there as well. Like here as well, I don't think I rammed hard enough down into all these bits. Some loose sand defects out this side. Also a few through here. So here you can see the comparison with the oil bonded sand. Much nicer surface finish. I'm pretty sure I can improve this finish a bit, probably just with better ramming, but it'll never get up to this quality. Hey, wait a minute. This engine's got a 2-inch bore. Don't tell me I made a typo of 54 millimeters and didn't notice it. I guess that's the last straw. It's not original. It's a copy of some 1970s or 1980s replica. It's not going to get used. It can take its place on the Hall of Shame. Now, one of the issues I've had with machining these is trying to get repeatable positioning. Because I'm fixturing off these tabs, but they're also casting, so they're not that repeatable. I was touching off inside these directions and then working from there, but flipping still gets a bit of inaccuracy. So I got a recommendation from Peter at Edge Precision to add one more operation before I start my previous op one, and that would be to fixture this off that combustion chamber and first just go around and bring each of these tabs to a known dimension. So to do that, I've printed up a 3D printed like boss, and I'll just melt a couple of inserts into it. Right, so I can pick up one of the existing screw holes, but I'll just have to drill a second hole in it for the bottom one and then bolt that down, and then put a couple more bolt holes further out and just put a strap clamp across to clamp the thing in position while I cut those ends. In my last video, I showed that this column is not perpendicular to the table. It's probably about 3 degrees leaned back. And some people pointed out that that's going to lead to cosine errors. You know, so if I'm measuring 1 or 2 microns, well, yeah, I'm going to get a cosine error. Whenever I see these comments, I kind of think maybe some mathematicians or physicists have, by mistake, ended up on an engineering channel, because I did some courses at the Technical University here in Vienna in mechanical engineering. And generally in the exams, they look at cosine of any angle less than about 10 to 15 degrees. You can just round it out. So what does it mean for this? The cosine of 3 degrees times a couple of microns ends up being down at around 3 nanometers. So about 30 atoms or so. Pfft, I can't measure that. Yes, this not straight column does cause cosine errors, but I'm not losing any sleep on them. Now you might be thinking, cool, we'll get to see Mark's new vise in action, but you'd be wrong. Because for this job, I need the small vise because I also need the second setup beside it. I was given this Haimer 3D touch probe from my mate Nikolai up in Denmark, and I must say I really like using it. If you've never used one, I would recommend it, so I'll leave a link. I realize they're not the tool for micron accuracy, but for just quick setups like this, it's great. You just dial it in till it reads 0, and then 0 that axis. So now X, and now Z. Right, so that was with my tool 999, which has no offsets, and so I can now set the tools I use relative to this one. Right, so now I'll switch to tool 11, which is just my drill chuck. Now I switched drill sizes, so I need to touch off its length. Now for setting tool length offset, a lot of people recommend that I should use like an automatic electrical tool setter. And I do have this one, but honestly, I don't really use it. And the reason I don't use it is mainly a wiring issue. What I would need to do is take off all of the machine covers, run its cable out of the enclosure somehow. Like I'd probably need to maybe put a connector up here or something so I can put this down on the table where it would be used. And the second thing is, of course, I never know what size parts I'm going to make, so I don't know where I would put this permanently without it being in the way. It's just a simple switch which gets broken. Linux CNC reads it. There are probing routines where you tell it to go down on a specific location until it makes that contact and then set the tool length. So I do have it, I could use it, but honestly, I've never got around to doing the wiring. It's kind of on the to-do list for the next time I pull all of the covers off and do like a major maintenance on the machine. So if I'm not using the tool setter, how do I do it? Well, this is a method which was recommended to me by Peter at Edge Precision. This is just a carbide blank. It's 10.5 millimeters in diameter, and it's very easy just to tweak this back and forth underneath the tool until it goes through, which puts me at exactly 10.5. So we've got tool number 11 set. Let's do G43 to set the tool offset, which is currently wrong. So G43 set, we've got a current offset, which brings us to 17, about 18 millimeters above. So all I have to do is go into that tool, touch off in Z, tell it it's now 10.5 millimeters above the stock, and tool number 11, which was showing 71 millimeters of offset, is now showing 63. And we've got the correct height above the work surface and the correct offset loaded. You know, thinking about it, I could have just used this as a template and drilled this on the drill press. You know, put a bolt through one and then drill through the other. But anyway, I needed a hole somewhere about here. So moving into the MDI, manual data input, I don't know, let's go G0, high speed move. We want to go to X80. And we're going to go to Y, what did I say, 54.8. We've got clearance. Oops, I guess I meant Y minus 54.8. Okay, a couple of screws through to hold my alignment boss on this side. A couple of standoffs. So now I can plop this down. Right, I hope that's now rigid enough to clean up these fixturing blocks. Right, well I'm all out of time on this video, but you can see here what I'm trying to achieve by machining these to a fixed position. It means I can position this to a known place, and therefore afterwards everything should line up. Anyway, that's all I've got time for this week, so I better run. I really love Greece, so if there's anyone watching from Greece, I'd like to say Yassis and Efharistopoli. Thanks a lot for watching, and I would suggest you next watch this video that comes up here, because it'll be just the one for you. See you next time.